Welcome to Chatting with Chuck. I'm your host, Chuck. Today I'm going to be talking about the IoT, and I get a question every once in a while, and it's how does industrial operating companies, they want to know how they can benefit from the Internet of Things. So I thought I'd touch on that a little bit. The Internet of Things, it continues to be a newsworthy topic, especially from a consumer-facing standpoint. Seemingly every vendor is producing an Internet connectable Wi-Fi smart device. It's able to interact with users through a mobile application or the cloud. While it offers consumers a level of convenience and entertainment, many industrial operating companies want to know how they can leverage the IoT technology to provide performance and value. So, a less widely reported subject of the industrial IoT, and some people call it the IIoT, which is a close relative to the IoT anyway. So where the IoT is more closely associated with consumer smart home devices, the IoT consists of a more robust class of manufacturing business equipment and devices providing sensing, condition monitoring, and automation. While these systems often can operate in a purely standalone mode, the real value is unlocked when they are networked to a large supervisory system. And once end users are able to make connections to these devices, a new world of information and possibilities is opened up. Suddenly, they have a rich source of data which can analyze in order to improve operations. Remote connection capabilities allows diagnostics and even control of the IIoT devices to be performed centrally, minimizing delay and travel cost. What I want to talk about is specific ways end users can find value in connecting the IoT devices into a larger system. In order to achieve this, a gateway device is typically required near the remote located IoT device. What these gateways do and their major characteristics is what I want to discuss, as well as how to begin implementing an IoT system gateway. So, let's first say what constitutes the industrial Internet of Things. Industrial operating companies are often already familiar with automation. They may have production lines with automated machines, package support equipment such as air compressors and chillers with onboard controls, or even environmental and HVAC systems able to supply status information. Sometimes laboratory equipment can supply information, and individual area sensors may include intelligent features and digital communication capabilities. While newer or more advanced sites might already have significant networking and automation infrastructure in place, IoT gateways are often needed to bridge the connection from various types of field devices. The very oldest and simplest of these devices may not have any digital communication capability. However, any equipment offers running and or trouble status contacts, and some might even accept an enabled or disabled signal. A gateway with basic input and output points is able to accommodate these most basic field devices. Simply newer field devices often include serial digital communication ports, which can be integrated to respond with data. Most IoT devices offer wired or wireless Ethernet links using some of the latest protocols and can even provide extensive data and configuration options. IoT devices may deliver many types of information, such as processed data or calculated data, maybe energy information, and much more. They can often be configured or commanded remotely. Taken together, this monitoring and control capability can be harnessed by users to improve operations. So how do we realize the value? Well, when it comes to the IoT, value is not achieved by winning a contest for a total number of data points collected. Instead, the raw data is far more preferable to gather actionable information and use it to achieve targeted results. Users can do this by implementing gateways to connect to the IoT devices, transforming their operations to realize true value. Let me give you a couple examples. Cost-effective data gathering, identifying waste, quality and performance tracking, predictive health monitoring, reduced maintenance labor. Of significant importance is the economics of using the IoT gateways as a data gathering method. There is no need to invest deeply in far-reaching automation infrastructures. Gateways are inexpensive and can be added as needed in a scalable manner. They progressively enable a new level of connectivity to users' existing assets. Once users are able to monitor field values, they can begin to identify waste. This can come in the form of excessive water usage, unusual power consumption, or even unexpectedly high temperatures. This type of monitoring can also be used to discover conditions impacting product quality. Equipment can be monitored throughput and holdups, fundamental to performance tracking. Some parameters, such as vibration, provide a degree of predictive health monitoring, allowing equipment to be serviced before it even fails. Gateways are a labor-efficient way of rolling out IoT connectivity initially and in the long run. Since they enable monitoring and control remote assets, they also save labor by allowing centralized personnel to access system conditions without wasted travel time. So what are some of the characteristics of an IoT gateway? Just as a common physical gateway controls access one area to another, an IoT gateway controls data flow among devices or systems, requiring connectivity and computing. Since a typical system requires many gateways, it is most cost-effective by the devices to have sufficient but not excessive capabilities. They must also be able to survive in remote and harsh environments. Connectivity matters both downstream to the IoT device and upstream to the supervisory network and system. Downstream connections may be Ethernet, but in many cases it will be legacy connections like a hardwire I/O or serial. Upstream connections will almost always be via more contemporary technologies like wired or wireless Ethernet or cellular data networks. From a computing standpoint, an IoT gateway must be capable of handling a wide variety of downstream and upstream protocols. It must also be able to route or map data from one protocol to another. While it is possible to create a gateway from a powerful PC, the expense generally makes this a poor option. It is far more suitable to choose a dedicated industrial device with just enough processing power and lots of connectivity options. Gateways provide a common and flexible translation layer between a wide variety of IoT field devices and a supervisory system. The data interface definition is performed at the gateway, which minimizes many modifications required to field devices. For example, machine builders have many good reasons to include IoT gateways on onboard their equipment. Automated equipment may use many different control elements and perhaps even more advanced features like IP cameras. Machine builders can engineer a gateway into their system to provide a simplified single point of connection for end users. This gateway can also act as a means of isolation, permitting users to read more monitoring data, but not write control commands. Since many vendors often multiple machine types and options, standardizing around an onboard gateway allows them to offer end user interface. So making the connection, how do we do that? Well, the first step in selecting the right gateway is to ensure certain basic features are present, such as competitive processor and memory, compact fanless industrial design, redundant power, video display capability, Windows and Linux OS options, wired Ethernet or Wi-Fi, serial, USB, and even hardwire I/O connectivity. It must have expandability, industrial field bus network expansion, mSATA, uplink features such as 3G, GPS, and GPRS. In the computing world, more processing power and memory is generally better. However, gateways are mission-specific devices requiring computing resources to be sufficient and competitive without adding excessive cost or energy usage. Also important is fanless operation for reliability over a wide temperature range, ability to use redundant power to maximize uptime, and small form factor. Displaying video locally makes it easier to perform onboard configuration and provides a degree of local human-machine interface, or HMI. Computing operating systems, the OS, such as Windows and Linux, should be supported. Connectivity options must match whatever IoT devices require, including wired and wireless Ethernet, serial USB, and hardwired I/O. Furthermore, the option to add expansion cards for field bus networks significantly extends the gateway's ability. More connection options means a given gateway model can become the standard device, simplifying the design. Similarly, multi-uplink options allows a gateway to work in large number of applications. With a given site, wired or wireless Ethernet are most common. However, remote locations are likely to need cellular data such as 3G, GPS, and GPRS. So what kind of conclusion, what's the outlook here? Well, smart equipment and IoT devices are widely available in industry and consistently increasing in numbers, but there are many different connection types and protocols, and physical installations are often hard to reach environments. While smart devices may operate just fine locally, the best way to realize their maximum value is to remotely connect them to a supervisory system so their data can be monitored. A flexible and full-featured IoT gateway built for industrial environments is the key to connecting a multitude of IoT devices to a supervisory system. Both end users and machine builders benefit from standardizing on a common gateway platform with the right performance and connectivity features. I just basically quickly went through gateways with the IoT. I've been summarizing all these thoughts, and I just kind of put it into a sheet form here, which you probably can tell that it just talked about it a little bit, so you can get kind of understanding of gateways when it comes to the IoT. I hope it might have been a little bit helpful for you, or I hope it was at least something you might be able to think about and help you make a decision down the road. This has been Chatting with Chuck. I'm your host, Chuck. I hope you stay tuned and listen to our further episodes.